Good day to everyone who's watching. In our lesson today, we're going to talk about coordinate geometry. Coordinate geometry is the study of geometric properties of lines, graphs, points, and curves. So we are going to begin slowly by finding the distance between 2 points or the length between 2 points. Consider the diagram here having points A, B, and then in the Cartesian plane there. So that is my y-axis, and then this one here is my x-axis. The coordinates of A there, x1, y1, then B there, it is the x2, and then y2 there. Then I'm having also another point which is going to be P there. Now, using my triangle LPB, there is a 90 there at P. So when I use Pythagoras Theorem, I'm having here my FB length FB squared is equal to the length FP squared, then plus length PB squared. So to get my length A to P, from point A to point P, I'll be subtracting the 2 there. So that's going to be x2 minus x1. That is my AP, but it is squared. Then plus PB, when I get the difference there, that is y2 minus y1 squared. Now my FB squared is equal to the other side. Now if I need the FB alone, this is going to be equal to, I apply the square root that side and the square root that side there. My FB is going to be equal to the square root of x2 minus x1 squared, then plus y2 minus y1 squared, then under the square root. So the length of any 2 points, I'm going to be using that formula there. Our example there, find the length between the following points, part A, P there, and the Q. My part A there, the length PQ is given by that. Now I come here, I nickname my points, that my point P, the negative 1 is my x1, then the 3 is my y, the negative 5 is my x2, my 6 is the y2 there. Then I come down here, I substitute them. So this is going to be square root of negative 5 minus negative 1 squared, then plus 6 minus 3 squared. This gives me the square root of, inside here I'm having a negative 4 squared, then plus here I'm having positive 3 squared. When I square 4, I have 16. When I square 3, I have 9. So this one is a square root of, when I add that and that, I'm having 25, and root of 25 is equal to 5 units. So that is the length of my points, or the length between points P and Q. Now this bar here up just means length, but when you go to vectors, to mean that PQ is a vector, they add an arrow there. So that is the difference there. Part B, my K there, I nickname the coordinates there. x1, y1, point L there. I nickname x2 and then a y2 there. So I come down here and then I substitute. So this is the square root of my x1 is the negative 4 there. Then minus my x2 is the 4 there squared. Then plus y1 is the 2 there. Then minus y2 is the 17 there. Then squared. So this is going to be the square root of, inside the bracket here, I'm having negative 8 squared, then plus, here when I subtract, I'm having negative 15 squared. Now, this is going to be the square root of 64 plus 225. When I add here, I'm having 289. And when I get the square root, I'm having 17 units there. Now, there's something I want to comment here. Even if I interchange, I call these ones x1, y1, and then I call this one here x2, y2, and I substitute them here the way they are, I'm going to be still getting the same answer. Why? Because when you interchange, for example here, this is going to be 17 minus 2, and you'll be getting positive 15. Here we got negative 16, but the square will always help us to give the answer as a positive, because the square means number times that number. So the negative number times the negative number will give us a positive answer. So even if you interchange here, we shall always be getting the same answer. So our part C there, I've now interchanged my x2 is the negative 4, then x1 is the 4 the other side, y2 is here, and then y1 is the other side. So when I substitute in my formula there, that is the square root of negative 4 minus 4 squared, then plus negative 1 minus 1 squared. So here I get root of negative 8 squared, plus here I get negative 2 squared. Square root of 8, square of 8 is 64, square of negative 2 is a 4 there. So when I add the 2, I'll be having the square root of 68. So I can leave the answer as the square root of 68, or I place the calculator and I write the answer to 2 decimal places, at least 2 decimal places. We can talk about the midpoint. If we have A and B with such coordinates and there are points on the Cartesian plane, I say the Cartesian plane is the XY plane. The midpoint of A and B is given by the formula here, x1 plus x2 divided by 2, comma, y1 divided by y1 plus y2 divided by 2 there. So even the midpoint is a point itself, but it is just that point in between point A and B. So this is the midpoint we are talking about. It must also have the coordinates which are given by those and those. If the A had x1, y1, and the B had x2, y2. Example 1, find the midpoint of points P and Q there. The midpoint is given by x1 plus x2 divided by 2, then y1 plus y2 divided by 2, I come nickname this one as x1, y1, x2, y2. Then I come substitute here. X1 is a 2 plus x2 is a 4, divide by 2. Then y1 is a 3 plus a 7, divide by 2 there. So when I add here in the numerator, I'm having 6 divided by 2. Then here 10 divided by 2. Then finally this one here gives me a 3, and then this one here gives me a 5. So the midpoint of those 2 points P and Q is 3 and 5. Example 2, find the midpoint of the points K and L there. The midpoint is given by that. You come nickname x1, y1, x2, y2 there. So this one here, I come and I substitute. This is 4 plus negative 6 divided by 2, comma. This y1 is negative 1 plus y2, which is 9, divided by 2. So when I add here, in the numerator, I'm having a negative 2 divided by 2. Then here in the numerator, I have positive 8 divided by 2. Then here I end up having negative 1. Then here I end up having a 4. Example 3. If point A is the midpoint of points P and Q, find the coordinates of Q. The formula of the midpoint is x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Just there. So we are going to get our point A, we put this side, then point P and point Q, we feed in here after nicknaming. So I need to let coordinates of point Q to be unknowns. Can call them x and y. Then I nickname here x1, y1, x2, y2. So my midpoint this side, which is the A, this is 3, 9, is equal to x1, there is 6 plus x as the x2, then divide by 2, comma. I have y1, there is 18 plus y all over 2 there. If these coordinates are equal to that, that means that the x value here is the same as the x value there. So that is my 3 is equivalent to 6 plus x divided by 2, multiplying both sides by 2. So this one I'm having 6 is equal to 6 plus x, because the 2 here cancelled. Then I take the 6 the other side. So I'll be having 6 minus 6 to get x, and I end up getting the x value as a 0. Then coming back here, the 9 is equivalent to that one there. 9 is equal to 18 plus y all over 2. Then I multiply both sides by 2. This one having 18 is equal to 18 plus y, because that one there cancelled. Then 18 goes this side. This is 18 minus 18 is equal to y. Then I end up getting y as 0. So the coordinates of point Q are 0, 0.